There is something strange happening on the world's oceans right now. Ships that could reach their destination in 6 days are deliberately taking 11. Vessels engineered to cut through open water at 25 knots are crawling along at 12. And it is not an accident. It is not a malfunction. It is a coordinated, calculated slowdown happening on every major shipping lane on Earth, from the South China Sea to the North Atlantic, from the Indian Ocean to the Gulf of Mexico. The question is why? To understand this, you need to go back to 2008. The global economy had just collapsed. Oil prices had spiked to nearly $150 a barrel before crashing violently. Shipping companies found themselves trapped between falling demand for cargo and fuel costs that were eating them alive. The math was brutal. A single large container ship running at full operating speed could burn 350 tons of heavy fuel oil every day. At peak oil prices, that was well over $300,000 just to keep the engines running for 24 hours. The economics of international shipping had become almost overnight completely unsustainable. Something had to give. A Danish shipping company called Maersk ran the numbers. Their engineers discovered something that would fundamentally alter how the entire industry thought about speed. When you reduce a ship's velocity by just 15%, fuel consumption does not drop by 15%. It drops by roughly 40%. This relationship between speed and fuel use is not linear, it is cubic. The physics are rooted in something called the Admiralty formula. Every small reduction in knots produces a disproportionately large reduction in the power required to push the hull through the water. The hydrodynamics had always been there, sitting in the engineering textbooks. Nobody had been motivated enough by cost pressure to act on it at scale. Maersk called this strategy slow steaming. In late 2007, they began testing it across their fleet on select routes. Within a year, these savings were undeniable. Fuel bills were dropping sharply, operating margins were recovering. Other companies watched and followed. By 2012, slow steaming had become the standard operating procedure across container shipping globally. Vessels that once averaged 25 knots were now running at 20 or below. Some pushed it even further to what engineers began calling a super slow steaming, holding speeds as low as 12 knots to maximize savings on the longest routes. The ships were arriving later, but for the companies running them, arriving late and profitable was far better than arriving on schedule and bankrupt. But here is where this story becomes more complicated than simple economics. When you slow a ship down, the ripple effects extend far beyond the fuel bill. For the global supply chain, operating at reduced speed meant that more ships were needed to maintain the same cargo volume on the same routes. If a vessel running at full speed completed a circuit in 30 days, a vessel running at reduced speed needed 50. To keep the same total cargo flowing, you needed significantly more hulls in the water. This created an entirely new problem. The shipping industry found itself with too many ships and not enough freight to justify running them at full capacity. Freight rates collapsed. Companies that had ordered new vessels during the boom years were now sitting on fleets they could not afford to operate at full speed and could not afford to keep idle at dock. Slow steaming had solved the fuel problem while creating a capacity problem that would take the better part of a decade to unwind. The strategy that saved the industry in 2008 became the structural condition it could not escape. The naval and strategic dimensions of this shift are ones that rarely surface in mainstream coverage. Military planners had been tracking the commercial slowdown with serious concern. The world's naval forces depend heavily on commercial shipping lanes. Supply chains for military hardware, spare parts, ammunition, food, and fuel all flow through the same corridors that container ships use. When the commercial industry restructures its routes, vessel sizes, and operating speeds, it changes the strategic environment that navies must operate within. The concentration effect was among the most significant concerns. Slow steaming encouraged shipping companies to build fewer but radically larger vessels to compensate for reduced throughput. Ships that once topped out at 10,000 containers were replaced by giants capable of carrying 24,000. When you load that volume of strategically significant cargo onto a single hull moving slowly through a contested waterway, the vulnerability equation changes completely. A single interdiction event, whether through attack, mechanical failure, or grounding, now removes from circulation a quantity of goods that would once have required 3 separate vessels to transport. The Suez blockage in 2021 demonstrated this with clinical precision. 1 ship, 1 grounding, 6 days. and the disruption to global trade was measurable from satellite imagery within hours. The event was not caused by slow steaming. But the reason a single vessel could create that level of disruption was directly tied to the industry's shift toward massive, slow-moving megaships. The concentration of value on individual hulls is a direct consequence of the economic logic that slow steaming set in motion. Naval strategists are now working through what it means to project force and maintain supply lines in an era when commercial shipping infrastructure is built around different priorities than military logistics require. The speed assumptions baked into Cold War-era naval doctrine simply do not match the operational reality of the current commercial fleet. But the slowdown story does not end with economics or military strategy. There is a third pressure now reshaping vessel operating speeds, and it is intensifying faster than either of the first two forces. Emissions regulations. The International Maritime Organization, the body that governs global shipping standards, has committed to reducing the carbon intensity of international shipping by 40% by 2030 compared to 2008 levels. By 2050, the target is net zero. The primary tool available to operators trying to hit those interim targets right now, before next-generation fuel technologies become commercially viable at scale, is the same tool Maersk reached for in 2008: reduce speed. The European Union began including shipping in its emissions trading scheme in 2024. Every ton of carbon dioxide a vessel emits now carries a direct financial cost for operators calling at European ports. The incentive to slow down has shifted from optional to mandatory. Companies that once balanced speed against fuel cost are now running a more complex calculation that includes regulatory penalties, carbon credit prices, and compliance timelines. What this means in practice is that the ships moving the raw materials that build modern infrastructure and fill modern shelves are traveling more slowly than at any point since diesel engines replaced steam propulsion in the early 20th century. The ocean is still there. The routes are still there. The technology to go faster absolutely exists, but the pace has fundamentally and perhaps permanently changed. The industry is actively searching for a technical escape route from this constraint. Maersk launched the world's first methanol-powered container ship in 2023, part of an accelerating push toward alternative propulsion. Rotor sails, modern versions of spinning cylindrical masts that use the Magnus effect to generate supplementary thrust from wind, are appearing on tankers and bulk carriers that would never have considered wind power a generation ago. Ammonia, hydrogen, and nuclear propulsion are all being studied with varying degrees of commercial seriousness. The technology roadmap exists. The question is whether it matures before regulatory pressure forces even deeper cuts in operating speeds. For navies and maritime strategists watching this unfold, the picture demands constant recalibration. The geography of strategic choke points, the vulnerability window created by slow and heavily laden vessels, the deep entanglement between military logistics and commercial shipping infrastructure, all of it is being reshaped by economic forces and environmental rules that simply were not part of the naval planning framework a generation ago. The deeper truth underneath all of this is that the speed of the global supply chain has always been a political and economic choice as much as a technical one. The era of maximum speed shipping, burning cheap fuel with no penalty for emissions, was a specific window in history. It opened in the mid-20th century when oil was cheap, environmental regulations were minimal, and global trade was expanding faster than anyone had predicted. It began closing in 2008. It is narrowing further now, and there is no credible scenario in which it reopens on the old terms. The ships on the ocean today are moving at the speed of a calculation. Fuel cost against operating speed, against emissions penalty, against delivery schedule, against fleet capacity, against regulatory compliance. The answer that falls out of that calculation on every route in every ocean is the same. Slower. The next time something you ordered crosses an ocean to reach you, that object spent weeks on a vessel moving at roughly the speed of a fast cyclist. Not because the engineering to go faster does not exist, because someone ran the full set of numbers and concluded that slower was, by every measure that currently matters, the only rational answer. The ocean has not changed. The physics have not changed. What has changed is everything we are willing to pay, and everything we now understand about what it truly costs to cross it quickly.